Hi there, welcome back. Today we have a fun project, another Arduino project, and this time it's a combined project where we combine several of the small experiments we have been doing along the way. So today's task is we have an object, some sort of object that's generating heat. Your task is then to measure the heat, display it in two places, and then cool the device. And of course I have already built the project, and the idea is we're going to measure the temperature, display it in two different locations and cool it with a fan. But we also want a override, so we have a button. When we click the button, we will start the cooling process continuously, regardless of what the temperature is. We also need to define a minimum and a maximum temperature of our desired device. That's basically what's going on inside your computer when cooling your processor, etc. So that's a fun little project, and we're going to use the Arduino. And the funny part about this is I built the project, used the code, and I'm about at the very limit of what the Arduino can handle, both in memory-wise and power-wise. So that's good. That's funny. Of course, it's not an ideal process to run your Arduino at the maximum of its capabilities, but yeah, sometimes it happens. We're just going to have some fun with it. The code and everything, I'm going to link to my blog. Unfortunately, my blog is in Danish, but if you want to, you can just go there anyway, and just when you find this video on the blog, just scroll down on the web page and you'll get schematics, and further down you'll get the code. Some of the comments, etc., might be in Danish, but shouldn't prevent you from copy pasting the code from the site. So let's get right into it and see what I have built. Alright, here we go. Here we have the project connected together. Let's see if we can fit that onto the screen. There we go. Entire project. Arduino in the center. Got a battery pack. I got my motor. I got a LCD screen. I got a relay. I got a OLED screen, and I got a temperature sensor. I got a button. Got a diode, resistor. That's basically it. All simple, basic components we have been going through over the tutorials, and we have just hooked some of them up together. Right now I have turned the backlight off in the LCD display, because if it's on, it's just going to be white on the webcam and we can't see anything. Right now you can still see barely something, but it says 18.8. And just like this one over here, it's hard to see on a bad webcam, but it shows the temperature right here. And it's updating every, I think it's 2 or 5 seconds. I think it's 5. Every 5 seconds it's updating the temperature. But it's measuring the temperature down here on this. It's called the TMP36. And it's hooked up to power down here on the breadboard. And the sensor pin is hooked up to the Arduino on A0 down here. A0 is an analog read. And when we're working with temperatures, that's of course analog. Beside that, we have a button on the breadboard. It's just hooked up to power on the left side, and on the right side button we have a resistor. It's just a 10k resistor. In case the power has nowhere to go, if you push the button, it would short out the circuit. But by adding the resistor, we would just put in a load instead. When I press the button, the power will run up through this brown wire to the relay and switch the relay. However, if you look down here, you can also see there's a diode, and that's preventing current from running back through this green wire over to the Arduino, because we also want to be able to switch the the relay with the Arduino, so we can use the relay both with the button and the Arduino. The relay is going to switch the power from the battery pack to the motor. That's all that's going on over here. As you can see, only 2 wires connecting. So the system is separated like this, and this battery pack and motor, and the control system. the two displays are hooked up. Of course they got a power and a ground, but then they are hooked up with a yellow and a green wire, both of them, and they all meet here in a very big row. So the green wire is the SCL and the yellow wire is the SDA, and two of them is just running back to the Arduino, meaning these two are showing different information on the same two lines. That's the I squared C. That's pretty cool. So you can have multi-displays on only two wires. So let's play a little with this. When I press the button, first of all, I should be able to turn the motor on. So let's try it. Yeah, it works fine. And when I grab this temperature sensor, the temperature should rise both on this screen and that screen over there. And I have set a threshold in the code that when we reach 22 degrees Celsius, the motor should start. That should be pretty fast. So I'm going to grab the motor and grab the sensor. There we go. And it starts the fan. It should turn off when it's below 21 degrees, so that should also be fairly fast. There we go, motor is off. That was the Arduino controlling the fan. So let's heat it up again. It's on, and let the fan cool it down. There we go. It's as simple as that, and that's basically how the fan system works inside your computer as well. It's continuously measuring the temperature on your device, and when it's too high, it turns on a fan, or even makes the fan go faster. You can make it go faster by adding more voltage. This is a simple system, so we just turn it on and off. We could extend the systems maybe with some LEDs like this one. And maybe we would have a green light, meaning the temperature is okay. Then we could have a yellow light, meaning the temperature is too hot and the fan is running, or should be running. And finally a red light, meaning if the fan is already running but the temperature is still rising, then we have a real problem or a error. So that's something we could do over here. We're not going to do that today, but it's just an idea on how you can expand the system like this. You could also add more sensors. The only problem with this is right now the backlight is off on the Arduino. But all these things are using so much power that the Arduino is unable to power anything more. So in reality, I should hook up the battery pack to this device and make it power the displays, the fan and the sensor, not the Arduino. If I turn the backlight on and turn the fan on, just pulling the relay is enough to make the Arduino not being able to keep the backlight on this small device. That's again, power consumption is something to consider when adding multiple devices into your system, so you need to be very concerned about how much power are you pulling through the small pins on the Arduino. Right now I'm using one of these replica Arduinos because they're cheap, and when I break it, not if, but when I break it, it's just going into the trash. Because, yeah. Let's look a bit on the code. Okay, here we go. Here's the code. Microsoft Coffee as always. First of all, this is very hard to see. It's very small, and we don't think we have any zoom capabilities in the Arduino IDE. No, we don't. Of course, I could start zooming on my screen, etc. But instead, I've copy-pasted everything into a program called MonoDevelop, and I got black background, very nice, and I can zoom, very nice. So this seems like a reasonable size. There we go. Let's run through the program step by step. So first of all, we are importing 6 libraries. The 6 libraries are used to run our code. The first 2 are wire libraries, which are used, well, I don't really think we need them anymore. Previously, we need to include these libraries to run things on the Arduino using wires. I don't think we need anymore, but because we're using some of these older libraries, we might need to include them actually. Anyway, These two are the Adafruit graphics libraries included from not the last video but the previous video where we talked about the small OLED displays. And this is the LCD libraries used to the LCD display. All of this is just copy pasted from those two examples previously shown in the previous tutorials. And the only new thing I have basically added is this part here so far. So initially we're going to define a integer that's a number, and we're going to call it temp1, short for temperature 1. You might argue we should call it temp pin 1 like this, because it's actually a reference to which pin number my temperature sensor is connected to, and it's connected to A0. Then I'm going to define two floats. Floats are numbers with decimals. So the max temperature, 22 degrees Celsius. Min temperature is 21 degrees Celsius. And I defined the boolean. Bools are basically a statement that is either true or false, allowing us to do some logic comparison. So I made a bool called fan, for the fan of course, and it's false by default. I also defined a pin which is connected to the Arduino. It's not really connected to the Arduino on that pin, but the relay is, okay? Then we have our setup. Nothing new here, I just took the basics and put it in. The only new things are these two. These two down here are pin mode, where we define the temperature pin, where we say to the Arduino, well, temp pin 1 is a input pin and the fan pin is a output pin, so please prepare to use those as such. Got these two commands which are new. I made them down below. So one is called LCD start and the other is called OLED start. So let's scroll down to them at once. They are at the bottom. So here we go. LCD start basically just shows the text on the LCD screen, and the OLED start basically shows this text on the OLED screen. That's it. We just show a startup text while the system is preparing, nothing more. Then up here we get into our main loop, or loop as it's called here. And we have a command called LCD temp, we have a command called OLED temp, we have a command called control, and one called blow. Finally, a delay of 2000 milliseconds. So let's start with the two LCD temp and OLED temp. I do believe they are right here, yes indeed. So they are exactly like the two startup commands, except in the LCD we have this, where I have a LCD print temp, and then I move the cursor to the right. You can see I move it to the right by 6, but I stay on line 0. That's because I have written some text that is 6 characters wide. 1, 2, 3, 4, 5, 6. And then I tell the screen to print this command called temp read. Before we go to what temp read is, let's take a look at the OLED temp. Just like the one before, except down here, usually we write print ln, as in print line, new line, after this text. We simply just write print, and again I write temp 1 colon and a space. The next command is a print line command, print ln, and I use the temp read parenthesis command, which we haven't discussed yet. So it's clear to guess, hopefully, that the temp read will show the temperature, or give the temperature as an answer. So let's see if we can find that. Well, it's right here. Notice how it's called a float, where everything else we make is called a void. And that's because this is a function of the function float. Yeah, that's silly now, but hey, just hang on. Float defines a number with a decimal. Okay, temperature is a number with decimal, and we use and refer to it as this name called temp read. Hang on. So what we do inside this function is we first read the analog pin where the sensor is connected. and we store it as T1 read. Then we take this number we read and times it by the voltage we measure. So this is where the precision of your sensor can be adjusted, because right now it says 4.7. What you really want to do is take something like a multimeter like this one and just measure the voltage across your sensor. So if you measure 5 volts, you type 5.0 right here. If you measure 4.5 volts, you type that right there. And that's basically our voltage reference you put in there. Then we divide it by 1024. I know we haven't discussed ADCs, which is analog to digital converters. But what you need to know is the Arduino can take any number you want and divide it into 1024 units. And that's what we are asking it to do right here. We are taking our new found voltage times the thing we read and dividing it into 1024 units. Okay? Then we take that unit and subtract 0.5, and then you ask why 0.5? Well, I don't know. That has to do with our sensor, and because we are calculating the temperature in Celsius, not in Fahrenheit. If you want the temperature in Fahrenheit, you have to use a different formula, but we're going for Celsius. Finally, times 100, and then the function has this command called return, which basically means when I ask the Arduino temp read, it will tell me T1C, temperature 1 Celsius. So what's happening up here? It's showing the temperature on the screen. That's it. Back to our main loop. That's a bit far. That's a bit far again. Come on. There we go. Then we have a function called control and one called blow. Let's go to control first. The control is where if you were using something called a PID controller, this is the place where you wanted to adjust your PID control values and of course write a PID control formula. A PID controller is just basically something where in our case where we have a temperature rising and we have a top threshold or maximum, the temperature will predict, the controller will predict when we are going to reach that temperature, and it's able to predict if I start the fan for maybe 5 seconds now, I can bend this curve so I won't surpass the temperature, but maybe go a little down again before I straighten out the temperature. And why is this important? Well, it's important because the way we do it, we are actually going to pass the threshold by some amount before actually being able to cool. The PID controller will also stop the cooling, so it will stay above the minimum threshold, whereas what we do, we will cool until we reach the minimum, and then the cooling process will actually continue. So our cycle will look like a curve like this continuously all the way as long as it's running, while a PID controller will also have the same trend, but it's much smaller, meaning it's using less energy and is much more efficient. But it's fine. In our case, we can do it the old way and it will still work. So what's going on here? We read the temp. Yeah, we just went to the function, and if the temperature is larger than the maximum temperature we defined in the beginning of the code, then we're going to set our fan to true. While it's true, we'll see what happens in a minute. If it's not larger, you can see it says else, fan is false. Okay, that's it. The control loop is done right now. Then we go back and we have the blow function or blow loop. The blow loop is this part right here. Not this part right here. And the first command in there is called while. While means while. So while fan, and then it says nothing. Normally you would expect equals true or something, but that's actually what it says. While fan is true, run this command. So when we enter the blow loop and the fan is false, it's just going to skip all this and set digital write fan pin low, meaning turning the fan off. If the fan is true, then it's going in here and updating our screens once again, because what's happening inside a while loop means the program will stay inside the while loop and it will not run this up here. So you need to do whatever functions you need to have done as well. Then we're going to turn on the fan. We have a shorter delay because we are running with a higher current now. We want to stop that as soon as possible, so our update rate is faster. We check the temperatures more often now. And if the temperature is then below the minimum threshold, then we turn the fan false, which means next time it enters this loop or exits the loop, it's going to turn the fan off. And then we need to write a very important command called break. If we don't use this break, it will just be stuck in here forever, or until we reset the program, of course. That's it. This is the program. Nothing more, nothing less. Very fun. Small little project. And we got ourselves a cooler. It's not a PI or PID controlled cooler, but it's a cooler and it's working. It's not a very efficient cooler, but for our project and our understanding, it's just fine, and you get a basic idea of how to cool a system or something that might be a generating heat you need to cool. And as mentioned, you can head over to my Danish blog and just copy paste the code if you want to. Thanks for watching. Comment, rate, subscribe. It really helps me out. Press that like if you like the tutorial or instructions video. Call it whatever you want. And I'll see you in my next video. Bye.